Hello, my name is Airin from CE2 and I will present my e-portfolio for physical chemistry. We will begin with the vision and mission of UTP. The vision is to become a leader in technology education and center for creativity and innovation. UTP has three missions. 1. UTP is an institute of higher learning. We provide opportunities for the pursuit of knowledge and expertise for the advancement of engineering, science, and technology to enhance the nation's competitiveness. 2. Our objective is to produce well-rounded graduates who are creative and innovative with the potential to become leaders of industry and the nation. 3. Our aim is to nurture creativity and innovativeness and expand frontiers of technology and education for the betterment of society. We'll then look through the program education objectives of chemical engineering departments. Engineers who are competent with the potential to become leaders in chemical process and related industries. Engineers who are committed to sustainable development of chemical process and related industries for the betterment of society. For the program outcomes, we will apply knowledge of mathematics, natural science, engineering fundamentals, and engineering specialization to the solution of complex engineering problems. We will also identify, formulate, and conduct research literature and analyze complex engineering problems, reaching substantiated conclusions using first the principles of mathematics, natural science, and engineering science. Here's the course learning outcomes. 1. We will understand the principles and theoretical aspect of ideal gas, first and second laws of thermodynamics, phase behavior, reaction kinetics, catalysis, and electrochemical systems. 2. We will analyze the complex problems of first and second law of thermodynamics, phase behavior, reaction kinetics, catalysis, and electrochemical systems. 3. We will design and analyze the lab experiment for thermodynamic, phase behavior, reaction kinetics, catalysis, and electrochemical systems. Throughout the semester, we have covered 6 chapters. The table of contents have all the chapters we've learned. The first chapter is Introduction to Thermodynamics. The second chapter is First and Second Laws of Thermodynamics. The third chapter is Phases and Solutions. The fourth chapter is Chemical Kinetics. The fifth chapter is Catalysis. And the sixth chapter is Electrochemical Systems. This semester, we have done a few quizzes and tests. In each quiz, there are 10 multiple choice questions. As you can see, that there are a few examples of questions from quiz 1 and quiz 2. We will then proceed to the samples of test 1 and 2. In each test, there are 3 subjective questions provided. Here are a few examples of questions from test 1 and test 2. All quizzes and tests were conducted online. I will then explain a few industrial processes. In distillation plant process, distillation is the process of separating the substances from a liquid mixture, which is homogeneous, by using selective boiling and condensation. As distillation involves boiling a solution and condensing its vapors, the composition of the distillate is identical to the composition of the vapors. There are a few equations used to describe the composition of vapor produced from a solution: Raoult's law and Dalton's law. Raoult's law states that a compound's vapor pressure is reduced when it is part of the solution and is proportional to its molar composition. The equation is P solution equals P solvent X solvent, where P solution is the vapor pressure of the solution, X solvent is the mole fraction, and P solvent is the vapor pressure of pure solvent. Dalton's law states that the total pressure in a closed system can be found in the addition of the partial pressures of each component. The equation is E total equals P1 plus P2 plus etc. By combining the two laws, we will get this last equation below. This shows that the vapors produced by distillation are dependent on each component's vapor pressure and mole fraction. The lead-acid battery is a secondary battery that consists of 6 cells and has a voltage of 12 volts. This type of secondary battery is used in automobiles, and they are capable of producing high current required by the starter motors. The reaction below shows how the process takes place in the lead-acid battery. In the lead-acid battery, dilute sulfuric acid is used as the electrolyte, which connects two electrodes. The cathode is made of lead peroxide, and the anode is made of sponge lead. As the chemical process occurs, the molecules from dilute sulfuric acid break down into hydrogen ions and sulfate ions. The hydrogen ions move to the lead peroxide because the cathode attracts the positive ions, whereas the sulfate ions move to the sponge lead because the anode attracts negative ions. When the hydrogen ions reach lead peroxide, they receive electrons from the electrode and become hydrogen atoms. This will attract the lead peroxide, forming lead-2 oxide and water. The lead-2 oxide will then react with sulfuric acid, forming lead sulfate and water. Some of the sulfate ions reach the sponge lead because they move freely in the solution. As hydrogen ions can gain electrons from lead peroxide and sulfate ions, those electrons to pure lead, there will be an inequality between the two electrodes. Hence, there will be a flow of current throughout the external load between these electrodes to balance this inequality of electrons. This leads to discharge of lead-acid battery. Catalysis is a process of increasing the rate of reaction by using a substance called catalyst. This process is used in industries because it makes the work easier, faster, and safer. An example of industrial catalysis is the contact process. The contact process manufactures sulfuric acid. Multiple reactions occur, including the reversible reaction, and it involves the presence of vanadium oxide as a catalyst. In stage 1, sulfur is combusted to produce sulfur dioxide. Therefore, sulfur has reacted with oxygen in the atmosphere. In stage 2, sulfur dioxide then reacts with more oxygen, producing sulfur trioxide. The reaction in this stage is reversible. Conditions required for this reaction are the catalyst of vanadium oxide, temperature of 450 Celsius, and pressure of 2 atmospheres. In stage 3, sulfur trioxide is converted into concentrated sulfuric acid. This is done by reacting with water. However, the reaction is extremely dangerous because it's highly exothermic and it leads to the formation of clouds of sulfuric acid, which can cause acid rain. So an alternative way is used in industries. This involves 2 processes. Sulfur trioxide reacts with highly concentrated sulfuric acid to produce oleum. Oleum then reacts with water to form sulfuric acid. Oleum is used to minimize the risk. Dynamic process is a process that consists of a forward reaction and a reverse reaction in equilibrium. This is called dynamic equilibrium. Dynamic equilibrium is reversible in nature, and it can occur in closed system. This state occurs in many different types of industrial process. For example, the Haber process. The Haber process is an industrial chemical process that manufactures ammonia by reacting nitrogen and hydrogen together. the reaction is reversible. The Haber process occurs in the compressor. Nitrogen extracted from the air and hydrogen obtained from natural gas are pumped through the pipes and into the compressor. In the compressor, the gas pressure increases to 200 atmospheres and it is heated to 450 Celsius. This produces a reasonably high proportion of ammonia. During the process, the iron catalyst is used to speed up the reaction. The reaction mixture is then cooled so that ammonia can be liquefied and easily be removed. For the reactants that haven't been converted to ammonia, they are recycled. Throughout the semester, I've gained a better understanding of the principles and theoretical aspect of ideal gas. First and second laws of thermodynamics, phase behavior, reaction kinetics, catalysis, and electrochemical systems by going through lectures and tutorials. In tutorials, we did exercise as practice to understand better on the topics and to go step by step on the complex. I hope you enjoyed this video. Thank you for watching.